Okay, we are live, Fletcher. So welcome. Thanks for joining us on the today's episode of the Secure Developer. So, and hello to everybody who's joining us in Slack as well in the live session channel. So, firstly, it may be the first time a lot of people are seeing me and my face. So, my name is Oliver Byrne. I'm a community manager with Sneak. So, I'm new, really about a month into working with the company. I'm working with Sam Hepburn, who many of you will know already. So today's session is about modern AppSec gotchas. So we have with us today, we have Fletcher Heisler, who's the founder and CEO of Hunter2.com. So hello and welcome to the session. So before we dive into today's content, we just want to make a quick note that we always are welcoming feedback on how we run these sessions. So whether you want to give us feedback across the Slack community, or you can find us on Twitter by searching for the Secure Developer. We're always interested in how we run these sessions, the content, the speakers, to make sure that it's of the most value to everyone. So any suggestions and feedback that people have, we're always welcome to those across the avenues. For today's session, for those people who are actually watching us on YouTube through the live stream, if you're not in the Slack community, we always encourage you to join us, and you can find the link on our website. And that is the best place to ask questions during the session, post-session. Our speaker, Fletcher, is actually in the Slack community and be able to answer the questions that you have, either during the hour that we have with us or post-session. And once the session is over, for anyone, you'll be able to watch the recording on our website. You can share it with your friends, colleagues across your networks. And just a final note that the Secure Developer is brought to you by Sneak. So our aim is to create a vendor-neutral space so where we can share knowledge and best practices related to security software. So that's the intro from me. So without further ado, I'm going to hand over to Fletcher, who's going to take us through today's session.
Thanks so much, Oliver. Thanks for having me. I've really enjoyed watching and listening to the Secure Developer. So hopefully I can continue the trend with some interesting, relevant content for you guys. Let me see. I'm going to share my screen and go over into slides here. Hello. Cool. We're going to be going over some modern AppSec topics today. I will be in Slack over here as well, so feel free to chime in with any questions or any additions that you might have. Many of you are likely going to be experts in some of these subtopics that we're going through. So feel free to add to what we're going over. This will be a really quick list of lots of different things. My hope is that many of them will be familiar, but there might be some nice reminders in there, as well as some new topics for all of you. Also, we'll likely not go for an entire hour, so happy to have discussion in Slack or afterwards. Sort of continuation from questions from within Slack. Cool. Hello. Really quick, background-wise, I am Fletcher. My company is Hunter2. I get called Hunter a lot. That's fine. You can call me whatever you'd like. Really quick about Hunter2. So I am a developer by training who has gotten more into security over the years, given lots of pen tests over the years, which is where a lot of these findings are coming from, sort of firsthand in the industry, what we're actually seeing when vulnerabilities turn up. Hunter2 focuses on training developers in writing secure code. So we typically work with companies giving interactive labs to their teams. So the engineers get to hack vulnerable applications and then get to practice patching them back up. We'll include a quick link at the end in Slack as well, but we just released Hunter2 Community. So that's basically the version for individuals. You can just sign up for free and try out some labs. And we've released a few that are pretty relevant to some of these topics that you can poke around in later on as well. So without further ado, many of you have probably heard of the OWASP Top 10 before. Industry standard, most common most common risks to applications. SQL injection, cross-site scripting, all that goodness. And for the most part, they haven't changed a whole lot over the years. So, we're going to be revisiting them with a slightly different lens as to what we're seeing out of the OWASP top 10 or potentially outside of that is most relevant to a modern web developer who might be using new technologies, but still falling prey to things like SQL injection and cross-site scripting. So how is that even possible? So I'm calling this the gotcha top 9-ish or so. This is not a scientific process, but just generally some thoughts from what we've seen in the industry and from modern web apps. But first, some motivation. So why do we care about this, and why does it happen? First off, rush deadlines. We all write code that sometimes we're not proud of because we have to get it done. And if that's the incentive, you can certainly push out something that you might have known a little bit better. There's the mysterious fix for a mysterious bug. We've all been in that situation of something's not working in my local development, but if I set this flag differently, it all works. Now combine that with the rush deadline, I might just set that flag and go about my day without taking the time to go in and figure out, maybe based on some hidden and not very clear documentation, what that flag does and why it might not be a great idea to flip it. Sometimes we just don't know better. Most of the time, we don't cover security in standard computer science, let alone web app development a lot of the time. So it's kind of up to us to sharpen our skills, or hopefully up to our employers to help us with that training. But that doesn't always happen. Sometimes it does, and we think we know better. And a lot of that comes often from poor training. If you're made to watch a really outdated video on here's SQL injection, and they show you a bunch of crufty stuff in PHP, and you go, yeah, but I'm a Django developer, I don't need to worry about that. Turns out you do, maybe less so, or maybe in different ways, but we could all stand to be more familiar with these topics. Sometimes we just don't think it matters, or we aren't incentivized to care. This also has to come from our management and from our whoever is guiding us in writing this code. If they don't care about security, maybe down the line we don't either. And so that has to be a team effort across the board. Sometimes requirements are just misunderstood or miscommunicated. I'd like to believe that's where a lot of these issues with password sign-ons and account lockouts, things like that come up that are very much meant for extra security, but end up sometimes doing the opposite or just very much inconveniencing users. Actual user requirements get lost along the way or miscommunicated. And finally, the cult of the new tool. So I want to try out this brand new thing, combine that with my rush deadline. Now I really don't know better because there isn't much documentation on it. There's not much community consensus on how to use this new framework or library. And so I end up writing really insecure code because there's just not a proven path for me yet. And so it's harder to do correctly. Cool. So without further ado, the gotcha top 9-ish or so. And again, feel free to weigh in on Slack. If I likewise get anything wrong, I might misspeak on something, or if you just have especially a way you've seen one of these issues come up in the real world that you're able to share, I would love to hear some of those stories. So we'll start out with security headers. These are basically for every request, every response, you have these headers that tell about the response before probably a body. There are certain headers that are security headers because they're very specific to security in terms of how the request is handled, typically by the browser. So we have a list here of ones that should commonly be included, but are pretty rarely included actually. And there are a couple sites where you can easily test what security headers are being included in a site. Can't think of the names off the top of my head, but they're easy to find. Things like that's really hard to say, XXSS protection. Pretty self-explanatory, meant to prevent against cross-site scripting. There are very few reasons not to include that as just an extra preventative measure, some defense in depth for your responses. X-frame options. So this is against things like allowing your site to be iframed inside of another website, and so someone could put your login page inside of their page and perform a phishing attack or something CSRF related. These are really easy to add. Some web frameworks actually start adding relevant settings by default there to turn them on. But they can't always guess at what you meant or how much locking down you might require for your application. Maybe you do need an application or some sort of service to be iframed, allowed on a particular domain. Make sure that you whitelist that one, but don't go too far. So, a nice little check mark, check list to make sure that you're including these kinds of security headers right out of the gate. Another one, content type options. So this is around specifically Internet Explorer most of the time, guessing at the content of a file and guessing at its type based on its content rather. So for instance, this ends up happening where you upload something, you say it's an image, but it's actually just JavaScript code. And then a browser, typically not modern browsers these days, but potentially, will helpfully guess that that is in fact JavaScript code and run it for you, or an HTML page and run the code in it. We have a couple others listed here. Strict transport security, which can be a bit of a foot gun. If you get it wrong and it turns out you wanted to load some content over HTTP, it's really hard to take back that option that is essentially trying to enforce HTTPS. Likewise, content security policy is not new technology, but being newly used, and definitely we're seeing a big uptick in usage for CSP. The difficulty there is setting rules correctly. This is another way of preventing cross-site scripting. And you can get very granular with what kinds of images, what kinds of even CSS, where scripts are allowed to be run from, different domains and so forth. The difficulty there, especially for a modern web app that's taking in lots of third-party services, is you end up saying, we think we have a pretty good idea of all the things we need. And then your marketing team works through a different channel and adds in another third-party tracking widget that you did want to whitelist, but you ended up breaking part of the site accidentally. So CSP has a reporting version in which you can essentially say, here's what we would have blocked. Highly recommend basically doing dry runs of anything you're setting up through CSP first. And for each of these topics, we're going to go over some good points and bad points about modern web frameworks. Now, a lot of my own background is in Python, NodeJS, more of the tech along those lines. So you won't see as much from .NET, from Java, things like that, but these are true across the board for any major framework. One gotcha is a lot of frameworks give themselves away. So Node Express, as an example, has a nice X powered by Express header that it adds to every request. Adds a little bit of overhead, that's not a huge deal, but it's also giving an attacker extra information about what kind of server you're running. And it's not really providing any useful information to the end user. So no reason to include it. You might as well not make an attacker's job easier. One tool that I recommend there is Helmet.js. So highly recommend if you're using Node and Express. Helmet.js has a lot of great defaults that probably should have been the defaults to start out with to help secure your app, especially around security headers. Rails in particular does a great job when it comes to security headers, just in terms of the kinds of defaults it sets. Now that doesn't mean that you're definitely secured by default all the time when you start a Rails project, because it can't guess at every feature that you're using, for instance, but you'll be on good footing there. A little bit about the host header in particular. So the host header says, hey, I'm coming from this domain. As with anything else in life and programming, don't rely on user-provided input. And the host header is essentially user-provided input. So that means it can be faked, which can lead to all sorts of issues. CSRF, webcach poisoning. One that comes up really commonly is password reset poisoning through there, where someone could send a phishing attack and send out a password reset request, but they're actually sending you back to their own attacker domain. And so you put in your current password along with attempting to change your password, and they have your credentials. In terms of framework gotchas, Django specifically, but other web frameworks that have similar, includes allowed hosts and some other standard configuration settings there. We see this really, really commonly. That's I think what probably happens is in local development, things aren't working. To go back to the mysterious fixes for mysterious bugs. But you find out maybe after some Stack Overflow driven development that if you put a star in allowed hosts, things work. And that's great. So let's leave it that way. And you might end up pushing out that code, and now you've completely disabled any of the security that comes along with having a whitelist of allowed hosts. So that's the sort of thing that we see happen a lot with changes between production versus local development, or things that could be a little extra time consuming for setting up in local development. Make sure that you're not working around those protections, even accidentally. Verbose errors. So a few different ways this can come up. Turning off debug mode. We obviously never include debug mode, but this is another that happens a lot for local development. Code gets pushed out, and then you're in production with debug mode on. Likewise, and this is especially true for teams working in services, microservices across different parts of an application and of a platform with lots of different teams working on lots of different pieces of code and APIs. You want to be very helpful, and so you provide lots of detailed information in your errors. That might not be a front end to you, and to the next team that might be, we need to turn the error up to the user to let them know what's happened. And so through this sort of game of telephone, you end up providing lots of backend details to an attacker who has managed to cause an error in your API, as an example. So that's the sort of defense in depth as well that I mentioned, where you need to make sure that you're protecting your service adequately, assuming that you might not know where that information is headed afterward. Another really common one is code comments. So the first thing I ever do if I'm helping out with a pen test or just looking over someone's site is I will go into the console and look for code comments in typically client-side JavaScript. Anything commented out that's a function that wasn't quite working, or maybe it was supposed to be run only locally or in debug. Likewise, you can look for to-dos or even just profanity sometimes to see what might be something that a developer left in and shouldn't have. This is the sort of thing that you can make sure to ideally strip out as part of your pipeline and going to production. No reason to have those comments left over for the production application. A few specific framework gotchas. Django REST framework, which is used for APIs in Python apps very frequently, has a really great browsable interface that is fantastic for development and fantastic for attackers trying to figure out your endpoints and how to abuse your API. So make sure that that is turned off in production. Flask gives stack traces that give a console. And so if you think of, oh, maybe we leaked a little bit of information here, it's probably not the end of the world. You can get remote code execution just from having that nice error page. I believe in newer versions of Flask, you have to have a PIN number to access it, something like that. But just to say, it might be a little bit more damning than just releasing an error code. Another thing that happens frequently is a stack trace will show surrounding code. So you might see something where, for instance, a secret key is hard-coded just above the function that crashed. And so that gets returned in your error message. Lots of ways that these can go wrong unexpectedly. Likewise, Rails reveals all of the routes available to you in debug mode. So again, a really great way for it to help out in local development and to help out an attacker, saying, here's every possible route I tried. Maybe try one of these. All right. Good old SQL injection, Bobby tables. Still happening, still one of the most common issues, and the advice is still use the ORM. This one is not too fancy, but every modern web framework comes with some sort of ORM, some way to interact with your models without writing raw SQL code. I think what ends up happening here is either folks are new to a tool, and so they find a lot of things like introductory tutorials that start with raw SQL because it looks easier and more common, or someone has used SQL before but has not used an ORM for that particular language. Or sometimes you want extra speed, and you think that, or maybe you're right, that raw SQL will slightly improve your performance there, but it's it's never worth any possible reasoning to write that raw SQL. So what if I want to? No. We were just trying out, and let me see if I can do this really quick as a live example. As a, let's say, developer new to Rails, if I wanted to find out an example of how to do a select statement in SQL, because I'm on a rush deadline, I'm on a new tool, I'm feeling lucky, let's just go here. And I ended up with a Stack Overflow post. Okay, as active 4 months ago, it's viewed 250,000 times. This guy wants to do something that's faster, so sounds good. We'll go to the select. Oh, that's got almost 400 upvotes and a nice green check. You can do this. Great. Let me copy and paste that and go back to my app. And now this is a little unfair to Rails because they have great documentation and warnings all over the place of not to do exactly those things. But it's easy to fall into those traps still. So there's a lot of not necessarily misinformation, but it's easy to not be fully informed if you're just taking a quick look through things. Likewise, NoSQL. This is a sort of MongoDB example. The equivalent of apostrophe dash dash. If you have sort of a greater than nothing, that is also always true in a NoSQL query. And so, a lot of folks will end up thinking, oh, it's not SQL, I'm not going to be able to inject things. You can inject code into just about anywhere if you take that raw input. And so that's still a problem that is becoming more and more common as folks move to things like Mongo for their databases. Yep, we've covered this. Cross-site scripting, one of our favorites. Don't pass HTML to templates. This is also pretty standard stuff that hasn't changed, although the methods by which we do so have sometimes changed as we get more and more layers of client-side JavaScript stuff happening. And so it gets more and more complex when we say passing HTML to templates, what that actually means and what inputs are going where. The standard advice is sanitize inputs early. Where that could go wrong, as an example from what we've seen, is, for instance, perhaps you're rendering Markdown based on some user inputs, which is already a dangerous idea. You might sanitize, which then changes user inputs and then pass it through a renderer, which changes user input again. And so a smart attacker possibly can use your layers of changes in sanitization to make their way through your filters. So just be very careful about the business logic behind how you're treating that kind of user input. This is a great one for adding linter warnings, just in terms of unsafe function calls or function calls that you probably didn't mean to or should have a very good, clear reason to call. For instance, the unfortunately named safe and mark safe Django functions are not safe. We've seen a lot of developers who think, oh, if I wrap this in safe, it will be safe, which is very reasonable. You're in fact marking that you believe this is safe input. And so you can wrap it in there to make sure that it's treated as raw HTML. React, I believe, did a great job with finally calling this dangerously set inner HTML. Pretty verbose. And yet we still see folks who are calling that for whatever reason to set dangerous, unsafe inner HTML. Not quite sure the reason there. It's definitely more rarer, but something that we can continue to aim to improve on with new technology and new frameworks coming out. I think we're heading in the right direction, and we're seeing fewer of those issues with things like dangerously set. XXE. So this is a new one when it comes to the latest OWASP top 10 categories. This is XML entity injection. And from the apps that we work with most often, we're seeing JSON rather than XML. And you don't always have that luxury of not using XML, but ideally that's a good way to go when possible. Just using JSON, again, it's kind of like just using NoSQL. You're not safe by default. We've actually, in that, the community labs, Duo helps publish a lab on JSON injection specifically to demonstrate how that's possible as well. So anytime you're using user inputs, it can be potentially injected. XML injections are really one that just won't go away for very unfortunate reasons. First off, we're seeing more and more parsing libraries over time. There's this explosion of, if you look at CVEs related to parsing and to XML and other related topics, you'll just see this exponential graph. And sure, there's more code every month regardless. NPM is a lot of this, where everyone is sort of reinventing the small wheel for their particular use case. But each new developer is running across the same bug and falling for it the first time around, at least. LXML, which is the underlying, I believe, C library that most all of these parsers are based on, sets resolve entities to true. And that is how XML injection happens, essentially, is you insert an entity which relates to a file that could be a file on the server, and it happily interpolates, here is the actual contents of that file for you. A lot of packages relying on LXML then say noEnt equals true, or rather, if you set noEnt equals true, you would probably, as everyone does the first time, think that means no entities. Make that true, and now you're protected. But it actually means there won't be external entities because we'll interpolate them for you, or we'll substitute them for you with the contents. So the configuration is the exact opposite of what you'd expect. And if you didn't read the documentation carefully, a lot of folks will end up setting noEnt equals true, even if they know about this attack and are trying to prevent it specifically. All right, checking Slack really quick. Looks like no questions quite yet, but feel free to weigh in with any questions or further thoughts as well. CSRF, cross-site request forgery. CSRF tokens, random tokens that ensure that you cannot use a form request a second time, essentially. use them. This is a case where, again, I've heard of CSRF. We're protected because I use whatever particular framework that includes CSRF protection by default. That's true if you actually use the CSRF tokens. So consider, depending on your setup, including them on every form or by default on every overarching layout template page. So if possible, you never forget because it's always there already. What I'd love to see, and maybe someone can help write this middleware. I don't think I've seen this in any web frameworks. At least some warnings when you don't include a CSRF token. They can't always, a framework can't always guess what you intended, and probably shouldn't be preventing you from doing certain things automatically. But if there is CSRF protection, it'd be great to know if you missed a bit there, and you have one particular insecure form or insecure post in a sea of automatically protected with CSRF tokens. So would love to see some motion there, but in the meantime, they're easy to forget. So consider just adding by default. A bit on authentication and authorization. We'll just plow through some topics here. Use strong password hashers. We don't see this too frequently, but we'll get to, and I'll spoil the surprise here. Flask login, as an example, uses poor encryption by default. Uses SHA-1, which has been broken for quite some time. There are some other very commonly used libraries that actually don't choose strong password hashers for whatever reason. So that's another case of always check the documentation around password hashing and make sure that you're only selecting secure options. You don't even have something that can default to a lesser, less secure version in some way if a user tries to force it in that direction. And review business logic very carefully here. So this is, I would say, one of the most common areas where applications, we'll see them fall prey to some sort of business logic vulnerabilities, weaknesses there, where it's often that there are a lot of related features around password resets, around the user lockout, around sign up versus login versus OAuth login versus who knows what else. And so you end up testing the happy paths. You end up saying, well, what if a user deleted their account, but then signed back up, but then did this and then did that? And those are all important to test, of course, because all your users will hit them. But what else could an attacker do with all of that? What if an attacker tried to reset another user's password? A lot of those also come down to often business trade-offs versus security. Things like, how quickly do I want to lock out a user account after incorrect attempts, for instance? Does that mean that an attacker could lock out lots of user accounts? So there are always those trade-offs there as well. A couple other mentions specific to framework settings. Cookie expirations. By default, most often your cookies will never expire for most every modern web framework. And you could argue whether that's the right decision. I'd say it might be very unexpected to find that you have a cookie expiration that you didn't set. Might be better to have to explicitly set one, but I think it probably comes as a surprise afterward to a lot of folks of, oh, our sessions never expire, we should add that in. So another piece to add to the checklist as you're setting up any new service or application. Cookies also allow for HTTP only and secure flags. The secure flag says, send this over HTTPS only. It often doesn't get set again because you might not be developing for HTTPS locally. And so setting it breaks it. And so you set that to false or don't set that at all. When that would be a great case for setting it specifically in production or getting a local environment that more accurately mirrors what will happen in production. HTTP only essentially says don't send this cookie through JavaScript requests, only to HTTP requests. Very few reasons why you would ever legitimately want to send it to a JavaScript request, and most of them are attackers trying to use things like stored cross-site scripting to get at user cookies. So very good idea to set that one by default, but it frequently is not in most frameworks. Known vulnerabilities. This one is also, I believe, new to the latest OAuth top 10 list, and is certainly exploding in terms of usage, and why we're seeing companies like Snyk having a lot of success. There's a lot of open source going on now. So PyPy, NPM, etc. Everyone is using more tools of other developers, other groups all the time. That's great. It's also dangerous. You're widening your attack surface to everyone else's code potentially as well. So use some tools, use some services to help warn and prevent and automate that. Scan your code frequently for those kinds of vulnerabilities. Python has safety. There are things like NPM audit that are automatically built in as you install packages now, and give you nice big red warnings when known errors have happened. So make sure that you pay attention to those and take heed of those warnings. Again, when you get to rush development and just need to get something out the door, that's the moment when you're going to say, I don't think that medium level severity risk is all that bad. We'll research it later, and then later comes and it never happens. And you get stuck on an older and older version, and it gets harder and harder to upgrade whatever that library was, based on maybe some breaking changes. So I would highly, highly recommend setting out rules for yourself ahead of time. Set up policies around when to consider and when to force of the upgrading of external code. For instance, every time we see something that is of critical severity, that's a showstopper. We cannot push that code to production. Every time we see one or more mediums, we're going to investigate this, make sure that there's not a current known attack surface given our code. And then over the next X days or weeks, we're going to make sure to continue to upgrade those vulnerable packages. Without those rules in place ahead of time, you'll never get around to helping out with updating those packages. So this can help to prioritize it when the time comes. Framework gotchas, I listed NPM just as a general set of vulnerabilities. NPM is great, but along with other libraries, not to just point the finger there, anyone can publish anything. And so you really have to do your diligence and say, what are open issues? Is the community, the wider community, using this library? Has it been around a while and battle hardened? Has it been thoroughly tested? Is it currently maintained, or has it just sat around for a couple years, potentially collecting some dangerous cobwebs? Another thing that can happen is lookalike libraries. Someone might, similar to, if I tried to get google.co, or probably not that one at this point, but something similar, someone might say, oh, this is express rate limit, except there's rate limit one word, and it does something that looks like the right thing, but it also steals a bunch of user data. So you have to be very careful about these sorts of vulnerable packages that can creep in as essentially, sometimes they do the right thing even. And so it looks like you're getting something for nothing, but it turns out that they also have a nefarious purpose buried in there. So make sure to do your research. Some other ways to shoot yourself in the foot, and a quick rundown of other things that didn't quite merit a category, but we've seen a whole lot of. Setting poor password requirements. which often means setting no password requirements. This is another thing that most modern web frameworks are not going to help you with. They might help choose a secure hashing mechanism by default. They might help with a lot of pieces like that. But it's up to you, for instance, to say at least 8 characters, or ideally, let's check against a common list and make sure that we don't accept that. If you have fantastic security and all your users are choosing password as their password, you don't have great security. HTTPS and incorrect redirects. We see this a lot of folks setting up HTTPS, but then not enforcing it or not redirecting to it properly. And so this can lead to a lot of phishing over still available HTTP. Poor DevOps. Maybe all the code is great, but you set an Amazon Web Services permission to be wide open, and someone can curl into your service or do whatever they'd like to your S3 buckets. One more area that developers get to be often fully responsible for without a lot of hands-on training. Open redirects, redirecting to another site. This is another one where you might be attempting through some feature, maybe it's the password reset as an example, to redirect to internal links only. But you're not checking whether those are just relative, and so you end up redirecting to an attacker's site as part of a phishing attack. Reverse tab nabbing, related and a whole lot less frequently talked about. It's not super common, but if you are including links out to external sources, most common way to do that is to have target equals blank, and you send someone out to a new tab when they click on that and go to a resource. So the difficulty there, if you're not careful about where you're sending folks, maybe these are user supplied new links. If you do not set the right attributes on that link, that href, little known fact, unfortunately, but that child tab, that child window, can access and modify the parent, which means someone goes to that new link, they go over, they take a look, they come back to your site, but your site location has actually changed to look like maybe a phishing site that's on a similar domain and looks like your site, but isn't at all. So it's something like relation no opener, and we go through the details in the link there, and we'll provide these slides at the end as well, but make sure that you're always setting those, again, for any sort of external links that you're providing. Likewise, if you thought that they were trustworthy, if now an external partner gets hacked, that could potentially open you up to vulnerability as well. So, just checking in on Slack. Okay, notes from Sam, cool. Another one that we see really commonly is passing sensitive data to third-party services. Very frequently, if you're using full story or other sort of analytics trackers, they try to do a pretty good job of scrubbing out things like password fields automatically, but aren't going to catch everything, especially if you're using lots of custom named attributes and in your fancy React app. So make sure that whenever you're collecting user data, you're not unintentionally siphoning that off to sensitive data off to places you shouldn't be. And keep in mind, there's only limited security that you can put in place for this, but whenever you provide an input field of any sort, chances are a user will eventually enter their password into that field. So just a thing to be aware of, and another reason to have good security overall, even if you don't think that it's for a particularly sensitive use case. You will end up dealing with sensitive data. Last one that frequently comes up is metadata left in media files. So often for helping an attacker get a foothold for phishing attempts, if you're doing things like uploading internal docs or PDFs or things like that, maybe even images, The metadata might be able to say, here's who created this file, or here's the old version of Windows that they're running at your company internally. So make sure that you're scrubbing metadata out of anything that gets uploaded as well, that might be revealing in unexpected ways. A whole section on read the docs. So a lot of the suggestions here can come down to review configurations, review documentation, be careful about what you're including in your application, review defaults. And I've fallen prey to this as well. That's when you're just trying out one of 3 or 4 different solutions, you just want to see if it works. You copy in that tutorial code, and it's been hours, and finally, the feature is doing what you want the feature to do. Quick commit it. Before you do that, make sure that what you just copy pasted is a sensible set of defaults and that isn't introducing any serious security vulnerabilities. Often a lot of templates in modern web frameworks will provide a lot of default keys and default settings. Things like secret keys for the application obviously should be changed. There are often lots of warnings and change this code comments around those. But again, if you get to the quick create my template, it might be very easy to just hop over to the next step without reviewing. These are the additional steps that you manually still need to take. If you want some scary results, just take a look on GitHub and search for, any of the standard secret keys that come with a lot of standard templates or framework generation tools out of the box, and you'll come up with a whole lot of results in applications that often really shouldn't have those defaults still there. So, setting up a prevention checklist. Here's a quick cheat sheet summary of a lot of these pieces. The first step in the checklist is have your own checklist. If you just take someone else's and it turns out even 30% of that isn't relevant to your use case, you're going to start ignoring more and more of it. And so that's part of why we did a little bit of everything here. You can pick and choose what are the most relevant pieces here and figure out for yourself, for your team, for your application, what is the most relevant checklist here. And especially as you go through a new application, you can go through that production checklist. Did I turn off debug? Did I reset the secret key? Did I do all of these things that's, maybe you only do once every few months or once a year. And so it's easy to skip over those afterward. Use the ORM, of course, no raw SQL, no exceptions. We didn't even talk about threat modeling, but I think there's a lot of a lot of benefit to think like an attacker. And so have you missed anything obvious when you're talking about that password reset feature? You went through all the use cases for a user, but what if you were nefarious? What if you were trying to abuse that function? What could you do about it? And especially for your particular application, product, company, even your industry, who would you expect an attacker to be? What information would they be after? What motivations might they have? And that can help you think about what are these kinds of vectors we should be paying attention to. If you're using open source, make scanning of some sort part of your pipeline, part of your production pipeline. Read the docs, of course. Always read default configurations, read through how something works, read through open issues as well. And review best practices. Pretty much every modern web framework has some sort of reference page at this point for best practices in security and for the decisions that framework has made for you. So even if you are an expert Django dev, especially when you're setting up a new Django service, it's great to go over that security topic page and just make sure that you haven't missed any parts. Maybe you're working with some new functionality there. Cool. That is it. thank you. And if you go to hunter2.com/secdev, as in the secure developer, that will redirect you to these slides, so you can access these whenever you'd like. We'll throw that in Slack. Likewise, feel free to go to community.hunter2.com to sign up for those open labs, just to try out some stuff firsthand. Let me double check. It doesn't look like any questions right now, but I'll be in Slack afterward. And obviously feel free to email me anytime. So hope this was helpful, and thanks so much for having me.
Thank you so much, Fletcher. It was great. It was lots and lots of information. And for anyone in the YouTube, again, we have Fletcher in the Slack community. So any question, feel free to ask them, and at mention I'm not frozen. I think I'm back, so I froze for a second there. So yes, again, thanks very much everyone for your time today. Like I said, we'll post the links that Fletcher's just mentioned in the channel, so you can access the slides and resources that we've gone through today. And with that said, we'll close the session there. And thanks very much everyone, and enjoy the rest of your day. And thank you again to Fletcher.
Thanks, Oliver. Have a great one, everyone.